Hey guys, welcome to another video. So today we're going to be going over some ACT and SAT math statistics, which make up about 8 to 12 and 15 to 20% of the tests respectively. So the basics to stats, and you guys can skip ahead if you already learned this, but essentially the three main parts that are crucial to statistics is mean, median, and mode. So mean is essentially just your average. So it's basically every term added together over the number of terms you have. So if you have a set of 1, 2, 3, and 4, you would just add all these up and divide by 4, and that's how you get your average. Median is essentially just, let's go back to this 1, 2, 3, 4 set, is essentially just the middle number. So if you have a set of odd numbers, you would just go one by one. So cross off 2, and then the middle number would be 3. If you have 1, 2, 3, or 4, the middle number would be the one right in between. So we would just find the average here, which would be 2.5. Mode is probably the easiest one. It's essentially just the most commonly occurring number in a set. Like in this case, 1, 2, 3, and 4, there's no repeating numbers, so there is no real mode in this data set. So with that in mind, we're going to go over some problems, and later on we're going to go over some other statistics like margin of error, z-score, and normal distribution. So our first question is going to be this one here. So pause the video first, try and see if you can figure it out. This isn't too much of a difficult problem. But yeah, so what we're going to start with is essentially we're gonna see that there are 10 students and the mean of their score is equal to the median. So our first step is that we have to make sure these numbers are in order, which looking, we can see that they are in order from least to greatest. So now from here, we can kind of just find the median by crossing off 1 on each side and just, so 2 and 2, 3 and 3, 4 and 4, 5 and 5. So the middle median would be the average of 80 and 85, which just to make sure, let's do 165 over 2, we get 82.5. So we know our median equals 82.5. So essentially, what that means is if the mean of the score is equal to the median, that means the mean, so 82.5, will equal all of these data points. Let's erase these crossed out numbers. All of these data points added up over 10. So over all of these. So from here we can just go into Desmos and essentially just add all of these numbers up. So let's just do that real quick. It's kind of tedious, but um, 80, 85, 85, 90, and 95, and we get a total of 725. From here, we just simplify the question down to by multiplying by 10 and subtracting, so we get x equals 100. So our value of x would be C, 100, and that would be our answer. It's a very easy problem. If you really just understand what a mean and median is, it's not too difficult to understand. Our next problem will be a little bit more challenging. In a similar it's in a similar format, but it's a little bit more challenging, and this comes from Blue Book Practice Test 4 for the SAT. So question 14. Pause the video once again if you would like to work on this first and see if you get the correct answer. But essentially what we're going to do here is we're going to realize that there's 75 buildings that have a mean of 32 meters. So the way we can write this out is essentially that everything added up, we'll say x, everything added up over the 75 buildings, so all 75 buildings added up equal 32 meters. And additionally, all 50 buildings, so which would be y added up over 50, would equal 62 meters. Now, we know that dataset C will be the total number of added, all the 75 buildings added up, plus all the total number of meters, like the height of all 50 buildings in dataset B, so y. And we can essentially just take that all over dataset C, which is 125 buildings, and that would equal dataset C. And from here, it's a very simple equation, as we just solve for x, solve for y, and plug it in. So let's just do that real quick. 32 times 75, 2,400, and then plus 62 times 50. So we get 5,500, and then we get 5,500 over 125, which our data set C would be 44, which is our answer. Again, very simple problem. It's not too difficult. The SAT and ACT won't really quite trick you too hard, I would say, on statistics. It's really just if you know it or you don't know it. And yeah. So now our next problem, we're going to get more deep into statistics and a little bit more information. But again, it's not too difficult. So this problem states that the SAT scores are normally distributed with a mean standard deviation of 500, with a mean of 500 and a standard deviation of 100, using the 68, 95, 99.7 rule. What can you say about the area for the portion of students who score less than 650 on the SAT math test? So essentially what we're going to do here is, for this question, is we have to know an important rule. So in normal distribution, which is essentially just this curve, there's a way we can divide normal. This is actually a really terrible drawing. Let's erase that and make it a little bit more symmetrical. But essentially, we can distribute like this. So when you have a normal distribution curve and you see these data points, anywhere from here to here would be 34% of the data. Anywhere from here to here would be 13.5. Actually, I forgot to make one more line. Anywhere from here to here would be 2.35. And the endpoint, if you add everything up, would be 0.15% of the data. So this is a rule you have to memorize. It's extremely important to statistics, especially for normal distribution. So essentially, what it asks us here is, what can you say about the area for the proportion of students who score less than 650? So we can apply this rule here by basically splitting this up into that rule. And so what we can see here is that if this is 13.5, this is 34, 34, 34, 13.5, and 0.15, we can use Desmos here and just add everything up. So we would do 0.15, which accounts for this small area down here, plus 2.35, which accounts for this area here. We could do 13 plus 13.5 plus 34 plus another 34. And now we are halfway. We are at 650, so we're halfway in the 13.5 area. So we can just do plus 13.5 over 2. And we get 90.75. And now essentially what we can do is just look at the answer choices, and we see that the area is between 84 and 97.5. That would be our answer, because our answer is right in between there. So again, normal distribution is not too difficult. I think it's just memorizing this 99.7 rule, the 68, 95, 99.7 rule. Just remembering those numbers, especially the smaller decimals, because those get more difficult to memorize. But yeah. Finally, we're just going to talk about like what standard deviation is. So let's write all this down. Standard deviation, margin of error, and how we would be using Desmos or our TI-84 to really help us with statistics. So most statistics can be done on Desmos or in the calculator. So since I have Desmos open here, you can kind of just open it up and see all of these statistics: mean, median, mode, standard deviation, VAR. So basically for the SAT and ACT, what I would really suggest is just we really only need like standard deviation, and I would say just like maybe if you need mean, median, and mode. But it's really simple. You kind of just put it in. You have some data. You put in some data points, and it'll kind of just find the standard deviation for you. But essentially, what standard deviation is in accordance to the mean, how many data points, how far are you from the mean? Um, a better way to put that is if I explain this through margin of error. Um, Margin of error is essentially like how off can you be while still being correct. So let's say there's a 13% chance that you have a disease, and your margin of error for your experiment was 2.35%. There's a formula to calculate uh, margin of error. I'm not really going to go over that formula. I don't think you need to memorize it for the test. But essentially, what you really just need to know is that if you have a 2.35% margin of error, that you could be at most 15.35% likely to have the disease, or you could be 10.65% likely to have that disease. It's essentially like just like plus minus, like you can think of it like that, plus minus of of what you're looking for. And yeah, so I think besides that, statistics are pretty simple. Most of these functions on deviation and things will be used later on, especially if you take like AP stats. But on the SAT and ACT, it'll be pretty straightforward. um, there shouldn't be any too difficult questions about stats. And later on, I'll be going over some of like the hardest problems I could find about the ACT and SAT. So stay tuned for that. And yeah, so without further ado, I think I'm gonna wrap it up here. Please leave a like and subscribe if you enjoyed the video and you learned something. If you have any questions, please leave a comment down below, and I'll see you guys in the next video.